Hello and welcome back to this video on learning design script. So in this video I'm going to talk about geometric primitives, which are basic geometric types in design script. So like most geometry functionality, we begin with import protogeometry.dll, and the most fundamental unit, kind of the fundamental type in design script, is a coordinate system, which represents, as you can see here, position in space, as well as an x-axis orientation, y-axis orientation, z-axis orientation, as well as rotation and scale on an object. So if we want to make the most basic and simple coordinate system, which essentially has the y-axis aligned on 0, 1, 0, x-axis 1, 0, 0, z-axis 0, 0, 1, with no scaling and no rotation, then we can simply create it using coordinate system dot identity. So this represents a coordinate system which is as you'd expect it, as you see it here. In other words, it's kind of not doing anything special to the geometry you're creating. So here we created this coordinate system, and you can see it right there. Alternatively, you can create the exact same coordinate system using coordinate system dot WCS. So it's just a different way of saying the exact same thing. Alternatively, you can actually specify a coordinate system in a particular position, for instance CS3, by saying coordinate system dot by origin vectors. And this takes an origin point. So for instance, we can say point dot by coordinates 1, 2, 3. I'm going to specify x-axis and y-axis. So here we can do that by simply grabbing the basic x-axis and y-axis from the identity. So coordinate system WCS dot x-axis system dot WCS dot y-axis. All right. So when we create this, we can see we have a coordinate system that's aligned just like the original coordinate system, but which has an origin at point 1, 2, 3. So we can create points and lines and other objects based on these coordinate systems. So if we take CS3, say, and we make a point, say point p is equal to point dot by Cartesian coordinates, we notice that this takes an input coordinate system. So we can say CS3, and then here I'm actually going to specify the x, y, and z values as 0, 0, 0. So when you run this, you can see the point is actually made at the very center of the coordinate system. Maybe I'll move it over 1 unit in the x-axis. So now we can see it's sort of moved over to this position here. But it's not creating based off this origin right here was on 0, 0, 0. It's creating it based off of this translated coordinate system. So here we're using a coordinate system to drive the generation of a point. So similarly, we can create several kind of basic geometry kind of solid types, kind of platonic solids. For instance, things like a cuboid, which is a kind of rectangular. So we can say cuboid by length. This again takes the coordinate system. We can say CS3, and then input, say, some value for the coordinate system, for the actual length, width, and height of it. So here we are. So here's our cuboid. You can see it's created at the very center of this coordinate system. And you might also note that there's no means of specifying, say, the origin of the cuboid. You specify the origin by putting a default coordinate system into the actual constructor. So there's a few other things we can make. For instance, we can make like a cone. So here's, we're doing cone by start point, end point, radius. So the start point might be my coordinates, say 0, 0, 10. The other point, the end point, then with a bottom radius and a top radius. So if we rerun this, resume, we can see we've created, again, a cone with a kind of bottom point, a base point at 0, 0, 10 here, and top point at 0, 0, 20, and then bottom radius and top radius. So the cone is kind of one more fundamental Platonic geometry type. We can also do things like spheres, as you might expect. My center point radius, so we might have the 0 point as I coordinates, say 0, 0, 0, and radius of 3, say. So there we are. This created, so here we've created several basic geometry types: sphere, cuboid, cone, which that and the cylinder are kind of the basic building blocks of things like constructive solid geometry. And so that covers the main fundamental solid geometry types. Thanks for watching.